Okay, we've got another way we can use all our coordinate geometry information, that is to prove some properties of triangles. So we've got many different sorts of triangles, and we're going to look at what makes them their sort of triangle first. So the types of triangles we've got, right back from year 9, is we've got a right-angled triangle. All right, what would we use to prove that? Right, 2 of the gradients and 2 of the sides are perpendicular. All right, one perpendicular, so that it's a right angle. All right, next one. We've got an isosceles. Oh, giving you a hint. Yes, we find the length of 2 of the sides, or all 3, and see if 2 are equal. 2 equal length sides. For an isosceles. All right. Equilateral. Same thing as the last one, but this time all 3 have to be equal, right? 3 equal sides. We can also have a right isosceles. So if we're finding out exactly what sort of triangle it is, we'd go and find out if one has a perpendicular angle first, then we'd find out if any of the sides are equal, because then we'd have a right-angled isosceles triangle. The other one with nothing in common, so no right angles and no equal length sides, is called a scaling triangle. So that's got the no case. Okay, so that's those ones. We did them in year 9, and now we're starting to see why we learnt these things. The next thing is about parts of a circle that we haven't learnt up to now. I mean triangles. So we've got this one. So this word we know, okay? Why do we know this word? Okay, because we're flying at an altitude of this. It's the height, all right? So again, with this triangle, it's about the height. And what we're trying to find is if we've got a base, what is the perpendicular height? All right? So if we're trying to find anything to do with an altitude, we've got to find the perpendicular gradient. So we might be asked to find the line that is the altitude of a triangle. How would we do this? We'd find a perpendicular gradient to whatever the base is. Perpendicular to the base first. So that means we first of all have to find the gradient of AB. Find the perpendicular gradient of AB. So now we know what the gradient is. And then we need to find the line by using C in this case to find the equation. Right, that would give us that one. The next one we want to look at is the perpendicular bisector. So, a bisector, what do you think that does? Cuts in half. Perpendicular is a given. So we want to find the line that cuts in half one of the sides. All right? So we've got a triangle. Again, ABC, I'm just drawing them all looking the same. And I'm going to change this time to this being the base. So if I want to find the perpendicular bisector to CB, I'm cutting it in half. So I want to find that point there so that those 2 lengths are equal. Then I want to find the line that goes perpendicularly through that point. So, stating what I just said, first thing to do, midpoint of CB. That gives me that point. Now I've got a point, I need gradients. So I need the gradient of CB. I need the perpendicular gradient of CB. And then I use 1, the midpoint, and the perpendicular gradient to find the equation. Right, so those are the steps. Okay, the last one is called the median. There's a lot of different things you can find median. All right, and what does median mean? Okay, it does mean, again, a midpoint, a median of a line. So if we've got up another picture, same thing. We'll go to the other side this time. So we're going to find the middle of this one by finding the midpoint, and then we're joining it to the opposite point. All right? So steps pretty easy again here. 1, midpoint of AC. All right? Then we need to 2, use the midpoint and B to find the equation of the line. All right, so if you follow those steps, you should easily be able to find out those 3 things. We have a lot of other things that we have too. We have if you want to go and find out some more things, you could investigate orthocenters, circumcenters. There's 4 different centers, all related to circles and triangles. So orthocenter, circumcenter, in-center, I think that's right, I don't know, and I can't remember the other one. All right, but if you've got some time and you feel like it, some of you guys might like to go and investigate what they are and how you might find the point that gives you, because it's a point. Each of those is a point related to a triangle and a circle in a different way. Have a look.